This lesson is a part of 6.5 of our complex numbers. So in this yellow box is the rule for polar form of a complex number. So earlier in our videos, we've talked about what a complex number is. So here is a complex number. It has the real piece A and the imaginary piece B. So that's what we've done in our prior videos. To create in polar form, so if we ask you to do a complex number in polar form, you're going to use this equation right here. Z equals R times the quantity cosine of theta plus I sine of theta. And then the A value is R cosine of theta. B is R sine of theta. The R value is the square root of A squared plus B squared, which that's your absolute value, if you remember from our previous video. And then the tangent of any angle is found by B over A. So it'll probably make more sense once we get to this next example, how we create it into polar form. So here's our example. Write a complex number in polar form. So here is our complex number, and we're going to just graph it out first. So remember, a complex number is Z equals A plus BI, where our A value is -2 and our B value is -2. So let's graph it out. So on our real axes, we're going to go left 2 and then down 2. So we'll end up right there. So let me erase that. So there is our complex number Z in a complex plane. Now what we're going to do is we're going to write it in polar form. Write this complex number in polar form. So we're going to use the previous slide to help us. All right, so here is our yellow box of our complex number, and Z equals R cosine of theta plus I sine of theta. Okay. So in order for us to start off with getting our polar form, we want to find the R value. So remember on the previous slide, our R value equals the square root of A squared plus B squared. So where is that in our graph? That is the distance back to the origin. So this is the R value, this distance from the complex number back to the origin. So we're going to substitute in the A and the B value into the formula. So A is -2 and B is -2. We square those values, 4 and 4. We add them together, and we get the square root of 8, and then we need to simplify it. So R equals the square root of 4 times the square root of 2, and square root of 4 is a perfect square, so we're going to get exactly 2 square roots of 2. So the distance that that complex number is from the origin is 2 square roots of 2. All right, the next part is we need to find out what is the angle, so we start with our real axes, and that distance around that angle theta. So we're going to be using, going back to our yellow slide here, to find the angle, we're going to use that tangent of theta equals B over A. So I'm just going to go ahead and extend this page. I can get it extended. There we go. So we're going to use that the tangent of theta equals b over a. Back to our b. This is our b value, -2, and there's our a value, -1 or -2. So the tangent of a, when we substitute the b and the a in, -2 over -2, which reduces down to +1. All right, now we want to find that angle measure. So we're going to use inverse trig. Theta equals the tangent inverse of 1. Now, you can use your calculator, or we might have that memorized already from Unit 4. When you take the tangent inverse with your graphing calculator or your scientific calculator, you're going to get 45 degrees or pi over 4. Pi over 4 or 45 degrees. That's considered also our reference angle. So if we go back up, this angle is not 45 degrees. It's actually sitting down in quadrant 3. So how do we find that angle? Is we have to add another distance of pi, or 180 degrees, to get down to quadrant 3. So theta in our quadrant 3 is taking our reference angle pi over 4 plus pi, or 180 degrees. If we simplify that, we have to change that pi to 4 pi over 4. So I can combine them into one fraction. So this is 5 pi over 4. All right, so let's go back up to our image. This angle wrapping around here to z, theta, is 5 pi over 4 radians. The distance we found is your r value, 2 square roots of 2. Now we're ready to go ahead and write it in polar form. So in polar form, we need this green equation. Z equals r times the cosine of the angle plus I times the sine of the angle. All right, so I'm just going to change colors here. Oh, it's annoying. Hang in there with me so I can extend this page. All right. So, to write it in polar form, we have the r value and the angle theta. So, the formula is z equals r, that distance from the origin to the complex number, parentheses, cosine of the angle theta, which we just found to be 5 pi over 4, plus I sine of theta, that angle. Now we substitute everything in. So our complex number in polar form, we substitute the 2 square roots of 2 in, quantity, cosine of 5 pi over 4 plus I sine of 5 pi over 4. So this angle is now in polar form.